Cool. We'll get started here. First off, just wanted to offer a quick correction. I think I sent a typo to Ron there. I graduated from the University of Manitoba, not Michigan. I am a Manitoba kid. So yeah, that's that. So just getting started, I'll be taking you guys through our project that we did here, installing this dual arm welding robot into our facility. So quickly, I want to just provide a brief background on our company and what we do. So we are Elmer's Manufacturing. We're located in Altona, Manitoba. So that's southern Manitoba. We design and manufacture agricultural equipment. We've got 5 major products that we make. We've got our Hallmaster grain carts, our Wolverine ditchers, Super 7 harrows, our Ravage bale processors, and we've recently released our Hive mother bins. For the sake of this project, we've focused on making parts for the Hallmaster grain cart. So that's the grain cart you see on the top right there. And specifically, we're looking at parts that are going to be on the undercarriages and the hitch. So the grain carts are a highly customizable product. The customer has a bunch of different options that they can select from. And so that's kind of where all of our variety comes from. We're a fairly fastly growing company. When I started with Elmer's around 6 years ago, we were under 100 employees, and now we're around the 250. And the other point of information here that's relevant is that we do follow a lean production system. So jumping into our robotics history, I think this is really important to understand kind of where we're at now and why we were able to be successful with this new project. We started our robotics journey back in 2014. So then we purchased a small robot. That's the robot that you can see on the top there. At that time, we actually operated under a batch work type system. So the robot did batch work of high quantity parts. And so jig changeovers weren't a huge concern at that time. We did all of our programming on the floor at the robot, and our fixtures were either fabricated by the operator himself or kind of a collaboration between the operator and our jig team. In 2019, we purchased a large used ABB robot. So this was a large robot on a track. It had 2 cells. That's the CAD screenshot that you can see on the bottom right. This was more the classic experience with the welding robots that Ron was talking about. We had lots of challenges with this thing. Our fixtures weren't super consistent, so our parts weren't repeatable. And there was also some challenges with the robot itself, like the welder had some challenges. Essentially, we ended up shelving the unit in 2022, and we sold it in 2023. So not a very good experience with robotics, but we did learn a lot. And we were able to apply that for our next units. So continuing with our robot journey, we made some significant advancements with our technology and our understanding of robotics in 2023. So we added some features to our small robot. We added through-arc seam tracking, which gives you the ability to track a weld seam as you're welding. So it lets the robot be a little bit more flexible for those parts that aren't super consistent. So essentially, I don't know if anyone's familiar with through-arc seam tracking, but the way it works is the robot will weave along an edge, and as it's weaving, it'll measure the difference in amperage, and from there, it can determine where that edge is and follow it. We added offline programming, so this gave us the ability to program parts off the shop floor on the computer, and then bring the programs downstairs. There's still some touch-ups required. We can't just hit the green button right away. But it did speed up our process significantly, and it allowed the robot to keep on running. So it helped us add more parts to the programs, or to the robot, sorry. We added what I call smart program. Essentially, we use touch sensing to identify if there's parts in the fixtures and then weld them from there. We also use touch sensing to identify different versions of parts so that we can have different versions using the same fixture and just kind of run one program. So simplifying things for the operator. So in the case of what you can see on the right-hand side there, there's 2 different parts. If we wanted to run that program with just one part in there, then the robot would go touch and see if there's a part there. If there is a part, then it's going to weld it. If there's no part, it won't weld and just go home. And then finally in 2023, we had a bit of a shift in mentality when it came to our fixtures and how we would place parts into the robot. So prior to 23, we looked at the robot as we want to input all of our raw parts and get a finished weldment. At this point, we started just adding tacked parts into the robot. So tacked weldments and get the robot to do all of the welding. There was a couple reasons for this. It kind of happened naturally. Essentially, we already had tacking jigs and we were already tacking these parts outside of the robot. So it made our fixtures simpler to just bring in tacked weldments. But what we realized is this gave us some flexibility now that we can either weld something in the robot or we can weld it by hand. We don't have to follow a specific process. So that was good. And it also simplified the robot fixtures like crazy and gave us better access for welding. And essentially our cycle times are about the same. The operator needs to do the work anyways to put the parts in. So whether he's doing it inside the robot cell or not, it didn't make a huge difference. Okay. So why did we choose a twin arm welding project? Essentially, at Elmer's, our long-term strategy is to develop these advanced manufacturing competencies. So we wanted to give it another go and get some more advanced manufacturing in the shop floor. We had previous experience in robot welding, so we wanted to apply what we learned on small scale with the small robot to now a larger robot. We learned a lot of what not to do with the ABB, so we felt more confident in jumping with a larger robot again. And the other part here was that we've got a fairly new team on this robot integration, and we wanted to kind of learn as a team how to successfully integrate a new robot into production with something that we were familiar. So we're already familiar with the robot welding. This felt like a good place to start, and then we'd have more confidence jumping into something that's less familiar. With robot welding, we've got some general safety improvements. So these are really heavy parts. We have to rotate them. So just taking that away from the operator is a good bonus. Also other general safety risks like welding smoke and burning and all that stuff. So taking that and giving it to a robot is great. We're expecting to see some cost savings, approximately 2-year payback with this project, improved quality and faster cycle times. So when we started the project, I had a pretty strong vision on how I wanted it to work. I joked around quite a few times about just push the green button, but that was a big part of it. Is we need this robot to be simple to operate, and you don't need to be trained in robotics to operate this robot. We don't want it to be scary. Already 2 arms is more complicated, and so I wanted it to be basically just hit the green cycle start button and the robot does the rest and it knows what to do. And I'm very happy to say we actually got that going. So like we've learned with the small robot, we wanted to tack our weldments before entering them into the robot. So we essentially just needed 1 cell for that. The robot has to follow a lean production system. We build things as our customers order them. And so we need to be able to do that with the robot as well. And the other part, we wanted our system to be able to accommodate for engineering changes. So we're constantly making improvements to our product and to our parts. And so our robot needs to be flexible for those changes. And we're also often adding more products to our production line. And so we need to have a system that's going to be flexible and accommodating for that. So quick project overview of how the whole system or project went. June of 2023, that's when we started the project. Basically identified all the parts that we wanted to weld, and that gave us the constraints for how we wanted that cell to look and the kind of different dimensions there. From there, we got some quotes from multiple vendors. We looked at doing different things versus like custom cell versus doing just one off the shelf. We looked at twin wire welding. We also looked at doing a dual arm versus doing a track. In December of 23, we ordered. So we selected all of our options that we decided to go with. We did the laser touch sensing and we did through our seam tracking. And then we also included a quick change system that I'll touch base on a little bit later on. In February of 2024, we started with our fixture designs. With that, we did some reviews with Innovair, which was the cell designers. Then we did all of our offline programming using Fanuc RoboGuide. We built our fixtures, So we had all of our fixtures and our programming done before we received our robot on June 28th. So that was a key thing for us to be able to get things done quickly there. June 28th, we received the robot. We installed it temporarily into our R&D facility. So instead of going to our production space, we went to R&D right away. The reason for that was kind of a learning outcome of the ABB, which was as soon as you put your robot into a production space, you're expecting it to pump out parts at the production rate. And we wanted to kind of reduce that pressure. So we had space in R&D. That's why we installed it there. From there, we did our first step programming. So we started with one of the simpler parts, try and make it easier on our programmer. We did our first iteration where we touched up all of the points. So the CAD to the real world didn't match perfectly, so we had to touch up some points. Second iteration was a soft run through. So essentially just running the program while holding the dead man switch in manual mode. And then finally, 1 week after receiving the robot, we got our first full auto run through. So pretty huge milestone, pretty big win for the team that we were able to hit the green button, have the robot weld apart and have a usable part 1 week after the robot came in. After that, we focused on programming the rest of the parts. We had 15 parts that we programmed. So that's touching up all the points. And now we're looking at moving the robot to our production space in 2 weeks from today. And finally, we'll do a pizza party once everything's running smooth. Quickly, we'll go over the specifications of our cell here. So like I mentioned before, it's a single welding cell, 2 arms. We've got the arms and the positioner mounted on a frame, so they're all rigidly affixed together. This is going to make it easy for us to move this thing around from our R&D facility now to production, and we won't have to do any tuning. It's also going to make it easy to move the robot around in the future if ever we need to, so we're not locked into a specific location. We've got a quick change fixture system. That's the picture you see on the bottom there. So what's really cool with this system is the system we purchased from Innovair. It's got RFID, fixture ID. It's got auto clamping, air pass-through, so this allows us to add pneumatics to our fixtures if we want to in the future. It also has induction inputs and outputs, so we can add sensors to our fixtures in the future as well. This system is key to the success of being able to do a lean system with a single cell and quick changeovers. Our cell is 16.5 feet by 20 feet long, and parts we can have up to 1,500 kilograms. We've got a 6-foot swing diameter and up to 16.5 feet length of parts. So some of the design considerations when we were working on our fixtures, we focused on a modular bolt-together design. This is something that we had proved out already with just our tacking fixtures and our tacking jigs for welding. Essentially, this does a couple things for us. First, it makes it easy to replace parts if ever they get damaged. Makes it easy to replace certain parts of the fixture when we make changes to parts in the future, or if a part of the fixture just really isn't working as we intended, it's not a problem. We can just unbolt that and bolt something else on there. So we use bolts and dowels to kind of locate everything in the right locations. We've got hole patterns everywhere, and then we can just kind of bolt things on as required. When we designed our fixtures, we focused on not over constraining the parts, so really limiting the amount of degrees of freedom that we're constraining and only doing it like the minimum required, basically to locate that part in space. We tried to limit the number of different fixtures that we have. So we have multiple different parts that'll fit in one fixture, just using kind of different mounting locations. So we have 15 different parts, and I believe we have 6 different fixtures. Theo might correct me on that, but it's something like that. When we're locating our weldments, we're locating them near the middle of the weldment. So what we learned with the ABB when we were holding our parts is we held them at the end, and this gave us more variation due to angles, and small angles over large distances end up being large variations in terms of linear dimensions, and the robot doesn't like that. So by holding our parts closer to the middle, we're effectively reducing the effective length and the stick out from that precise location, and that helps reduce that variation due to angular changes. And we're also locating our parts on fixed locations that are well constrained on the tacking jigs. We didn't limit ourselves to doing changes to fixtures. We also looked at part changes. So that wasn't out of scope, and it was also key to help us be successful there. So we did make some changes to how some of the slot and tabs fit, making things fit tighter or adding slots and tabs just to make the parts a little bit more repeatable. And we also did some adjustments of edges, so how much parts stick out, just to make the rope easier for the robot to weld, and it also helps with seam tracking in certain locations as well. So operating sequence of how this whole system works for us, essentially, you've got the operator loading a part into a fixture here while the robot's running on this one. Then once the robot's done this one, we will basically unload this, move it here, take this fixture and part, put it in, and then hit the green button, get the robot running. And then while the robot's running, we can unload the old part, load a new one, and just kind of be ready and keep on going that way. So essentially, when we hit the green button, the robot will scan the RFID tag that's in that fixture. And then from there, that'll load kind of a generic program for that fixture, which will trigger the robot to use laser touch sensing to find what part specifically is in that fixture. And then once it knows what part's in there, then it'll load the correct program and start welding. So a project like this doesn't come without any challenges. One of the challenges that we didn't anticipate was getting parts to program. So ideally, if you're bringing in a robot, you'd love to do consecutive parts or multiple parts of the same thing in a row. So basically do 3 small axles in a row, and then you can kind of tune in your programs. But we were using parts from production for production. So we had to kind of plan with the schedule and be flexible with the schedule. So we had to kind of do some bouncing around, which was a little bit challenging. Some of our old tacking jigs just weren't as repeatable as we thought or were hoping. So we had to do a lot of touch sensing and seam tracking with certain parts. Our CAD to real world didn't match, and we weren't as close as I was hoping. So there's probably a little bit more investigation that we can do there to kind of improve ourselves in the future. On the project planning side, that was a bit of a miss on my end. I assumed that as soon as we placed the PO, welding cell, and that we'd be able to start with our fixture design and our offline programming right away. That wasn't the case. So we went with a custom welding cell. So when we hit the PO, that was the trigger for Innovair to start designing the cell. So they obviously didn't have it available for us. So that delayed us in terms of being able to start our fixture and fixture design and programming. However, we were able to catch up on that schedule a little bit with starting with our fixture concepts and just leaving some dimensions loose and just kind of tidying that up afterwards. Some more challenges. Bigger is harder. So there's some inherent challenges just with having a bigger robot cell. Moving around on the cell is challenging. Seeing what you're doing is challenging. We have to walk basically under all those tubes to get to the other side of those parts. So that's just harder than a small robot. We had some random errors with our seam tracking software. And thankfully, our programmer and Innovair kind of worked through it and figured it out. There was some settings in the background. And finally, we had to work on rebuilding confidence after our ABB robot failures. So with the ABB, a lot of our welding staff had to spend a lot of hours grinding out some welds that didn't hit the right targets, or we had porosity. And there was a lot of jokes during this project about having to order 70 different grinders to deal with the grinding that we'd have to do here. And so managing those stakeholders and building up that confidence that this robot was going to be successful, that was a bit of a challenge, but we did make it through. Some of the things that made us successful, We have really strong buy-in from management. They believed in us enough to purchase a second robot even after failing on the first one. Stakeholder management. So we did involve our welding staff quite a bit with our fixture design and our concepts, and even just our whole operating sequence to keep them bought in. And we involved them as well with reviewing the parts once they came off the robot. We got their feedback on maybe how can we weld things in different orientations so that we meet all the quality specs that we need. Our quick change fixture system, I think this is probably one of the coolest parts of this project and one of the things that makes it super successful for us, especially in a lean environment. It's really, really good for that low volume, high variability. It keeps the programming super simple and the operation super simple for the robot operator. Their modular fixtures have been super helpful as well. So we had some concepts that didn't work out, and we just had to replace small parts at really low cost and low time investment. Tacking the parts outside of the cell is big for us. So with this robot, we're realizing now that this thing can weld faster than one tacker can tack a part. So we essentially have two tacking stations that will be feeding this robot. Offline programming and having all of our programs ready before the robot got here. We only have one programmer, so that programmer was then on the floor once it got here. So it just made everything more streamlined to have everything ready ahead of time. Then finally, having the robot set up in our engineering shop was a good thing that we did. Essentially, it removed that pressure of getting parts out right away. And it also removed the amount of eyes looking at it. So when you have challenges, people aren't starting to ask questions and doubt the capabilities of the robot. Having a strong partner, so Innovair was a very key part into us having some success here. They helped us with reviewing the fixture designs, then they offered their expertise there. And they were really quick to respond to the questions that we have and help us out there. We've got a dedicated team to this robot. So I've got a full-time programmer, and my programmer also knows how to weld, which is has been a really big part of the success here. A lot of the programming tuning that we do is for the welds itself. So having someone that knows how to weld and knows the effects and what they need to change to get the outcomes they want has been super big. And I've got a full-time engineer on this project as well. So this guy's been responsible for doing design of the fixtures, jig changes to the parts that we're tacking beforehand, and even any changes to the parts that we're welding inside there. He was able to help out with that. The last point that I want to highlight here is that we already have a checklist system in place to support process changes. So essentially, we've got a checklist for our welders. When they're tacking a part, they have to go through these things and they have to make sure that they've done all this stuff. And we have to make some process changes to accommodate the robot. There's certain welds that we wanted them not to do. There's certain welds that we needed them to do where we don't have access because of the fixtures. And so having that checklist in place already just made it super easy for us to communicate process changes. It was just a matter of adding a line into the checklist instead of trying to change a whole process and trying to figure out how people are going to remember to do the changes we said they would do. So our current status, we've got 15 out of 15 parts programmed. Everything's basically ready to go. We're at an average of 3/4 of a second per line of code to implement a part. Takes us an average of 5 samples to get a program dialed in and ready for production. We're moving to our production space in 2 weeks. We're going to continue to make small program improvements and kind of just dialing things in and making it better. We're an average of 2 3/4 times faster than manual welding, and we've demonstrated that we can do a changeover between parts in 5 minutes, which is pretty sweet. What's next for us? We're going to create a system to automatically capture run data on the robot, and then we're going to create a dashboard with that. We're going to display that on a TV next to the robot. We also want to add some videos onto that TV so that when we're doing shop tours, people can see what the robot is welding without having to peek through the screen and get blinded by the UV lights. We're going to look at adding parts mid-program. So a lot of the axles that we have, they're like a box structure, and we end up doing a lot of welding on the inside. Right now, this is the tackers that are doing that beforehand. And then once they've done the welding, then they cap it off with the last plate. With the quick change system and having that air pass through and those inputs and outputs, we want to look at adding the parts mid-program. So the parts would be fixed somewhere in the jig and then pushed into place by the robot, and then could be welded, all of that. We're looking at potentially adding 3D vision to be able to bring in parts that are more complex and vary more. And finally, we're going to look at automating other areas of our production space. So that's what I've got. Thanks for taking the time to pay attention to my presentation today, and I'll hand it off to Brent for the Schnell part of the presentation, and I'll be happy to answer any questions later on. Brent, you're good to take over whenever.
All right. Hey, everybody see that okay?
You bet.
Yeah, looks good.
All right. So yeah, welcome everybody. Jean-Marc, you did a great presentation. That was awesome. I even learned a bunch of things there. So there we go. I'm gonna have to come see this thing in action. Yeah, so our scale is a little smaller here. We did a bit of a smaller robot system. And yeah, we'll take you through it. Who are we? Schnell Industries, been around for 30 years now. I've been here for 20, and kind of grassroots. I've done a lot of welding. I've swept the floors, and they call me president now. Anyways, so I don't really have any, design or engineering background. I am quite self-taught. I've got a great team around me here and been really, really fortunate in that way, and a lot of talent here. So that's been key to our success. And yeah, let's dive into it. So we've got kind of these 5 things we're going to go through: the about us, the early days, where do we come from in our entry into robotics, and our growth and upgrade, and then our operational experience. It's been a journey. It's been fun for the most part. We would say we're innovative. We are very diverse here with what we do. We build a lot of different products, and we're in many different industries. We're not just in ag or just in industrial. We're everything from oil and gas to agricultural to a lot of other OEM products that we build as well for other companies. So it's extremely wide variety, and we utilize our robotics on many of these projects. And so it's got to be pretty versatile for us. Currently, we're at about 90 staff, and we were at 30 staff about 2 years ago. So it's been some pretty heavy growth here, and a lot to keep up with. Located in Winkler, kind of the best place in the world. Just a little bit of bias there, probably. Great place to live and work, and awesome community around us here, and amazing workforce to utilize as well. Everybody here likes to work and work hard, and we take that to our full advantage here, and it's been a success. 70% of our product, I would say, has been exported, mostly into the US, some overseas, and wide variety of industries that we cover. As you can see here, we've got our transloader conveyor. That's our product line. We've got that planter hitch, bottom left corner, and then we have our sweep all line on the right hand side. We acquired that a good number of years ago, and that's been a good success as well. And then we also do a lot of contract work, like I've been talking about, concaves for combines. The K-Hart air seeder, the Spider, we've been building that one we're on our 5th run here right now with them, running a batch of 40 right now through for them. And then we've done work for Conveil, which is, I guess, now Meridian, and some other contracts out of the US and Mexico as well. So it's been been a very interesting journey of kind of never saying no, but sometimes saying wait, and we get it done. So yeah, early days, just the consistency on high throughput parts was always a challenge, as anybody would know. I would tend to say that Southern Manitoba, we probably have a better, higher work ethic than a lot of places in the world. I'm not saying it's the only place, but it's definitely great. And so I was a bit of a doubter on the robotic side. Is it actually something that's going to be beneficial? We've got guys who work hard, who work efficient. They come here to work. They don't come here for the paycheck only. And so I was a bit of a doubter myself. I will be honest. We had the opportunity on a project, and the only way we could do it was with robot. And so we decided we would try it out. So yeah, in January 21, we got a contract, and that was a challenging one. Combine concaves, and it is many, many small welds. And we tried a few by hand, and we could not get consistency no matter what we try, even with jigs. A lot of warpage. And pretty much we determined, if one person only welds, then we could get some decent consistency, but add more people into the production line, slightly different speed of welding, a little different heat setting, and the warpage was out of control. And that's where the decision was, we have to do robotics, and we found a used unit and bought a used unit. Not going to say that was the best decision, but it was probably not a bad decision either. It was a low investment, low risk, and we had knowledgeable staff. We had one person on the team here who was really knowledgeable, and it really helped us propel this thing forward. And here's a shot of the unit, of the part, a little closer up. And it was a good machine, 400 amp, air cooled. Air cooled was the part that I didn't like the most. We melted a lot of things down, well, a lot of heavy parts, and it just didn't hold up. But we did increase efficiency, 84% increase on efficiency overall. We said, hey, that's good. It's still a win, even though it's been a challenge. We did not have DTPS, so no offline programming. Everything was a manual, stand in the machine and program it. Absolute pain. And it was a real trial by fire. There was almost no straight welds on this thing. Everything was a curved weld. Everything was a radius. All your positionings for every weld had to be moved. It was a fairly complex part, and then not to be able to do, offline programming. It was kind of one of those do or die situations, and we decided to do it. And we fought through this thing, and we came to the point where we had to do more parts that were different in these concaves, and it was just their machine wasn't holding up. And we knew what we did not like, and so we had to make a decision. What are we going to do, right? Here's a real quick shot of our old robot here. Just a bit of a time lapse. We did a bunch of hard surfacing rungs for the concaves with hard surface wire, which was a real pain. Went through a lot of consumables. I don't know, it was ridiculous. Probably went through, 10, 12 consumables a day on a good day on the tips. It was ridiculous. And so not efficient as we felt it could be. But for us, what was key for us getting into this was the critical skill development of our people, of our staff. And then fixturing, having a good fixture design is imperative, good jigging, and then collaboration on the programming, between design and the guy doing the programming. That has been great. Having the right people on staff, 100% key. If you don't have people who are fully confident that they can do this, not saying you shouldn't do it, you probably just got to send them for training. So we invested quite a bit in training. On our robot, not so much on the first iteration of a robot. It was, I would call it a semi-failure. It paid itself off, but it wasn't lucrative by any stretch of imagination. And so we knew if we were going to take a second stab at this, we're going to have to change our approach and actually invest in training. Going back to the low risk investment that I talked about, I guess we were pretty cautious at the time getting to robotics. We didn't go and dump a few $100,000 into a robot. We think we spent probably, $75,000 on our first cell. It was small. It was a 1400 Panasonic. It was small, but it wasn't very efficient compared to modern technology. It's like a 14-year-old machine now. And so definitely a challenge. The crawl, walk, run strategy that you hear about in robotics is definitely key, I would feel. I know there's a lot of push into the cobot world, do your cobot thing. That's kind of a whole different thing, honestly. I wouldn't even put that on the category of crawl. I would say starting with a lower risk, more automated robotic system is probably more on the crawl side, and then grow. I would say we're probably in the walk stage right now. We've got a machine who's running. It's doing, efficient work. We can do 2-3 shifts a day if we want to, no problem. And it really cranks out. So then in January 2024, we acquired our new setup. Was a Miller Performark system, and essentially off the shelf system, so not a custom one. And it was the key things to us were, the touch sensing, seam tracking. That was all very important to us, and a water cooled system. Keep everything cool. It is pretty amazing. The water cool system was our first venture into water cooled guns, and it is absolutely phenomenal. Like we can go, we might replace one contact tip in a day just because eventually of the wear, but not because you're melting it or burning it or any of that kind of stuff. So those kind of decisions were key to us. We knew what we wanted there. We do a lot of heavy parts, 3/8 inch, half-inch beads on a pass, and also a lot of small stuff. So we needed the variability of running, 035 wire. We also wanted to run 045, 052 wire, and this machine could handle that no problem. The touch sensing, seam tracking really helped our programming ability. Having said that, we don't do a lot of parts that have long passes. So from my knowledge of this, the seam tracking isn't something that is hugely beneficial on short passes. It's more about you got to have a longer pass. That's where it becomes a real advantage. The touch sensing is good as far as calibrating quickly between parts. We had a quick change system that we developed as well that really helps that. You drop in a new part, within 5 or 10 minutes, we can switch out to a different part and be running on a totally new part, no problem. With a matter of just 2 bolts. It was just removing 2 bolts. I don't know if I have any pictures of that in here. I don't believe I have that in this presentation. That is my bad. I should have added that. But yeah, the hookup was real quick. I mean, it was just install, your gas, your power. We put exhaust hood on it. It was a matter of days, and we had that all hooked up and running the machine and running test programs on there. We had programmed a lot of parts prior to us getting the robot, being it wasn't off the shelf unit. We had the complete cell in our DTPS and just started programming parts right off the get-go. And pretty much we hit the road running as soon as it landed on our floor here. So yeah, ability to weld multiple weldments with a single setup, A side, B side. So it's a rotating system. I don't know if this volume is covering up my sound or not here. We'll just watch through it. All right, so yeah, it doesn't show the fixturing too much in there. We got a quick change fixture with a self-centering system. It's just 2 bolts kind of into a tapered cone system that drops it in there and makes the changes really super quick. A side, B side, so the arm is just fixed on the one side, the table rotates around, and you're changing the part while it keeps welding on the other side. So sometimes it's a mad scramble just to keep that machine going. I think we'll see more in the efficiency stuff here. So kind of 3 different levels here are, manual welding, old robotic welder, and our new one. And just kind of taking a look at that time per unit based off of all the same weldment here. It was about 50 minutes to manually weld this part, which also required 2 people. But the 15 minutes included both of those people's time added together. And so it was just kind of flat 50 minute production time per part. Our old robotic welder is where it got kind of squirrely. Kind of a 25 minutes plus 6 days is what I'm saying here. So the 6 days is kind of our fixturing, setting up, programming. It was absolute painful. And then, 25 minutes on the changes and that kind of thing. And so it was very intense changing parts. So very inefficient. However, once we were going, we were at 25 minutes apart. So we're roughly twice the speed. I think earlier I had mentioned 84% faster. So yeah, between 84 and 100% faster. And then with just one employee handling all of that. Going down to our new robotic welder here. 15 minutes setup, 1 day of programming to change between parts. And I don't know how many parts we have programmed, but it's a lot. I would venture to say it's 20 or 30 SKUs that we've got programmed into our system by now. And it's very quick to set it up from the DTPS, load it in the system. It's 1 day of checking over, touching up, running a couple samples, and then it's off to the races. And so your initial investment setup time is significantly less. And then you have your it's a 15-minute production time. So we're going way faster now, from 50 minutes all the way down to 15 minutes on that same part, which has been absolutely phenomenal. So yeah, there's kind of your evolution of how we did it, how the timing worked out for us. You got to have DTPS software. There's no way around it. You got to do it, even if you're on the smaller side, not on the big scale. You want to be programming the stuff at the computer, click point, add your information, and make it happen. It's super slick. So yeah, a lot of continuous training, learning is happening on this thing here. Our partnerships, we bought this through Lindy, and they've been phenomenal supporting us through all of this. The Miller guys that come down and do all the training with us has been second to none. I would highly recommend. We would not say we have any negative experiences with our new implementation here. We learned some valuable lessons, like make sure the water cooler is turned on. Don't have somebody go back there and turn the thing off. You will melt down parts in your gun. And so we learned that lesson. But other than that, I don't think we've had anything major as far as painful stuff in the learning and teaching processes here. Having the key people is so important. If they don't know, but they're willing to learn and they're trainable, 100%, they can be a programmer and they can be an operator. Operators, they don't even necessarily have to be, knowing the programming. It's pretty much like Jean-Marc was saying, green button, go. For the most part, that is our experience here too. Sometimes you run into, a part that wasn't tacked correctly, and you run into a bit of a hiccup there. But for the most part, with our good jigging and stuff, it's been good. And we just have one more video here, just showing some of the parts that we program. A lot of the stuff is small. Small, high repetition stuff is a lot more of what we do. I will just run this one. I'm not sure if there's sound on this one or not, or how that's going to work. Let's see here. So yeah, it's all sped up. There you go. A little bit of dopamine for you there. So kind of closing this off here a bit, but you can see our setup here. We have 4 concaves in this robot at one time. And if you remember on one of the previous slides, it was only one. So one person is going in there and putting 4 of these in there, clamping them on, and then that thing does its thing. And it's just incredible, the efficiency you gain by not having that that start stop as often. For the most part, that robot would run, 12 to 16 hours a day, continuous when we were doing these concave parts. And we could have one model on one side. On A side, would have the Case ones. On B side, would have the John Deere ones. And we could just back and forth this thing all day and be spitting out both styles at the same time, not just one model of part. And then, yeah, lessons learned and future improvements, hands-on training, commissioning was enabling the practical training, equipping operators with skills for effective operation. It's just been great having the resources with Miller. I think we flew our guys out for some 3 days of training, and they came back, chomping at the bit to make this happen. Operators got immediate feedback. It was quick communication with our vendors on any questions we had through the setup and through the programming. We had Miller was here themselves for the initial, I think, 2 or 3 days of operational experience here. As we were setting it up, we brought this thing right into our production facility, being it's small enough that wasn't too big of a hiccup, and pretty much got to work within the first week there after we had the thing fired up and got going. We had a little bit of a spell from the time that the machine arrived till we actually had the parts to flow through it for this project. There was just a little bit of a lull in work there. So we had probably a 3-week, 4-week spell from the machine sat here that we weren't actually using it. But that wasn't because we were trying to figure things out in the machine. It was more just waiting on a parts flow. So long story short, robots are awesome, great machines, but without the trained and invested people, it becomes pretty useless and it's a heavy boat anchor. As mentioned earlier on, hire the qualified people, then train them, or hire the people that have the appetite to learn this thing and train them. You'll never get done learning when it comes to these robotics, it seems like. So yeah, that's pretty much it. We've loved it. It's great. Come on down sometime and take a look at our setup here, some of our jigs and fixturing. It's something we don't mind sharing. No real secrets around here. Just plain getting work done. So thanks, guys, and been good having you.
Okay, thank you very much, guys. We're going to get to the questions and answers here. If you have any questions of our presenters, please feel free to add them into the chat feature in Zoom. And I am just going to get this just a sec here. All right, I'm going to start with a question I have for both of you guys. I'll ask Jean-Marc first. When you guys brought in your welders, did your workforce actually see them as a bit of a threat? Or did you have to sell the idea to your workforce? Or how did that go? We'll start with you, Jean-Marc.
There's a bit of both, actually. So they saw it a bit of us as a threat, and then they also really like to point out all the mistakes the robot made. So as soon as we had the first part out of there, they were very, very quick to point out, oh, it's off here. Oh, there's a bit of cold lap there. And so I think it was a bit of a threat. Now we're at the point where it's kind of saved their butts a couple times where they were running behind on something and we just threw it on the robot and it got it out in an hour and a half instead of 3 hours. And I think they're starting to see the value from it.
Okay. Hey, Brent, you any thoughts there?
Yeah, similar. We definitely had a couple of staff who really pushed back and were like, okay, so this thing is coming for our jobs. And I had to tell them, no, it's not. It is literally here just to keep up with our demand and with literally the things humans can't do. And that is pretty much perfect consistency and repeatability. And they warmed up to it after a bit. We had the one robot for quite a while already, but it hadn't been doing great. It hadn't been a win-win for everybody. There was a little bit of doubt. I wouldn't say it was a big deal to, win them over, but there was definitely some hesitancy on their behalf. Would I do anything different? I don't know if I would. Now, if I was, trying to replace half my people with robots, that'd be a problem. But Yeah, no, it's been a good experience.
Excellent, excellent. So let's get to the questions here. Lance is asking, and this I guess would have been during your presentation, Jean-Marc. One of the pictures shows a person in the cell while it is running. What safeguards are in place, and what did you have to do some sort of provincial inspection?
Yeah, good question. So the provincial inspection or whatever inspection needs to happen, that was done by Innovair. So that was our integrator. When they designed the cell, they had to go through that whole safety thing. In terms of safeguards, there are light curtains. So there's a light curtain before you enter the cell, and there's also a light curtain that kind of scans the entire floor of the cell. So if someone actually walks in there, it'll stop. And if someone is present in there, it won't kind of let you go. So it'll even detect a coffee mug that's on the floor. So it's fairly safe that way. The picture that you saw of someone being in the cell while it's welding, that's in manual teach mode. So while the operator's in there in teach mode, there's a dead man switch basically that he's got in his hand on the robot programmer. So that allows him to be in there to actually watch what the robot's doing in a safer way, I guess. And also in manual mode, you don't get full speed on the robot. So there's some other safeguards there.
Okay. Anything to add on your setup there, Brent?
Ours is the standard light curtain. It's nothing as intense.
Okay, sounds good. Looks like Lance has been busy here. Lance is asking, would it be possible to detail the 2-year ROI? Did it include the programmer and support staff when you did your numbers?
It did, yeah. I don't remember exactly all the specifics of it, but it did include the programmer and support staff. It included the overhead. Basically, 2-year ROI was based off of running during the day shift for the first little bit, and then doing a day shift and an evening shift later on. So I don't remember exactly all the specifics, but that was roughly that. And I believe that the funding that we got from VTC helped with that as well.
Okay. And Brent, your ROI, just approximate on that.
I know I said it was 2 to 3 years at some point. I don't know if I had it in the slide here, but I know ours, I would say, is roughly that 2 to 3 year mark. I'm not defining it down to an exact 2 years. It kind of depends on our contracts in and out flow. If this thing was to be running, 16 hours a day, it would probably have an 18-month ROI, but it's more running like, 8 hours a day. So it's probably closer to the 2.5 year mark.
Okay. Okay. Any cons that you've seen so far not having a robots on a track?
No, not really. Having it on the track when we had it with the ABB, it just gives you more problem or more chances for error, I guess. Having the two arms, it makes it a little bit more tricky to program. You do have to worry about your arms hitting each other. And so depending on how we program, we can either program the robots to be completely in sync, where they're doing the exact same motion, or we can program them individually. So they're kind of running on their separate programs, if that makes sense. And in that case, then we really need to make sure that they're not going to go and hit each other based on their sequence. And so we can use wait commands and stuff like that. So that'd be the biggest challenge of not using the track. But the track versus the robot arm were relatively close to the same cost. And when you add a second arm, you just get so much faster. So that's the main reason why we went to the arms and not the track. I hope that kind of answers the question.
Excellent. Excellent. Chris is asking, in terms of efficiency and quality, how much of the improvement did Elmer's achieve with the transition to this technology? And I guess, Brent, that would apply to you as well.
So yeah, for us, efficiency, like I mentioned, is about 2 3/4 times faster right now. Quality, we haven't measured specifically the difference. However, I will note that at our last monthly meeting, our CEO was walking through the shop on his way there, and he noticed our hitches that came off the robot without anyone pointing them out to him. So you can see the difference in quality between a robot and a person welding it. It just looks so much better.
Yeah. Brent, anything to add there?
Yeah, there's more quality, more consistency, I would say. I have a lot of guys who it's actually a little hard to tell if it's a robot or the guy who's welding it. I have some really good guys. Now, when you get to the big, long, heavy welds, a robot is definitely going to be more visible, I would say. Uh, but being able to just take the parts out of the robot done, and some of them no scraping required even, and there's pretty much zero spatter.
Yeah.
That is one visible thing.
Yeah, awesome,
Yeah.
awesome.
And to add on that quality note too, the robot's really good at doing those long welds without stopping. So it reduces the amount of start and stops that you have, which reduces the amount of crack initiation possibly and all that stuff. So it's better in those situations.
Excellent, excellent. How are you managing fume control with the movement to more robotic welding with increased arc time?
That's a good question, actually. It's something that actually came up as a challenge. I had it on the slideshow and then I took it off. But essentially, when we had the robot in our engineering shop, we've had some welding in there before. We didn't think that the fumes would be a problem. Well, this thing welds a lot more than a human does, and we had a lot more fume problems. So um, we'll evaluate once the robot gets into production. We have a lot better air circulation in there, but we might need to add a fume hood on top of there. We already added a fume hood on top of our small robot.
Okay. Brent, did you have to upgrade your ventilation at all or no?
Kind of. We just moved the same hood we had from our old robot onto this one. It was pretty much a drop and fit on there, and it just exhausts directly into our air ventilation system that we have.
Okay. Okay. Slavka is asking, this is for Brent, what kind of offline programming software do you use?
So it's we just call it DTPS, I guess. It's a Panasonic desktop programming software, which is apparently what DTPS kind of stands for, which is kind of a lame terminology if you ask me. No fancy name there, but it's the Panasonic. We use the G3. Panasonic is our controller, and it's just the correlating software they send with the package. It was just kind of part of the deal.
Okay. Okay. For Jean-Marc, were cobots ever considered, or did you make the decision early to have industrial robots?
Good question. We did look at cobots. When I looked at them, they didn't make much sense for our application. Essentially, there wasn't much of a cost or a payback period for them. With the cobot being a slower machine, just because it has to be slower for operating around people, we weren't expecting it to really be faster. And the other thing is for us with our parts are all super heavy. So we need that auxiliary axis, which is in turn kind of removes the whole cobot part of a cobot because they haven't figured out how to make that safe with people yet. So with needing that auxiliary axis, the industrial robot was kind of the way to go. From my side also, like I'm not super sold on cobots yet. The whole point of them is to make them easy to program on the shop floor. And I'm not sure I want to go that route. I like having our programs done offline on the computer and then the program sent to the floor and not having to adjust programs very often. So I haven't found a huge win with cobots yet, especially on the welding side.
All right. Uh, okay, again for Jean-Marc, no, sorry, we did that one. Martin is asking, how many engineering, programming, fixture design staff are actively involved on a daily basis to keep the robot busy?
From our side, it's one. So I've got one engineer that's basically dedicated to support that robot, and that's going to be between fixture design and part changes, and then programming. I've got a full-time programmer. At this point in the project, the engineer is starting to be more removed from the day-to-day on there because all of our fixtures are designed and it's more so focused on the programming.
Brent, on your side, who do you have in fixture design? How many people in that?
Just one person, and it would not be full time. It's often a combination. It's kind of between two different people, but even that is kind of fairly part time for us for our scale here.
Okay. Question for both of you. Like, I know, Jean-Marc, you're not quite in production yet, but how many hours a day is it running? Are the robots running today in a shift?
Today, we're probably doing 6 hours running today.
That's pretty darn impressive. How about you, Brent?
Nothing today. We're kind of between projects, but we were for 4 months there going 16 hours a day.
Unreal, unreal. And you guys just received these things in like summer, early fall. That's impressive. For Jean-Marc, was there consideration to adding an A side, B side style of machine to keep it running while loading?
Yeah, we looked into it. When we did our quotes originally with both the A side, B side versus just a single cell. And we actually designed our single cell with two servos so that we could actually take a servo and move it to the backside and add a second cell if ever we needed to. However, I was fairly confident that we'd be able to keep it running with a single cell. So the quick change system is key there. Essentially, we can load our parts outside of the robot, and then we just have to load the fixture in there. And like I mentioned in the presentation, it takes us 5 minutes to switch over between parts. And so having that second cell, the reason we decided against it was that it was going to increase the footprint of the robot significantly. And now it's dedicated for robot space, whereas having our loading and unloading separate from the robot, now I can kind of put that wherever there's space on the production floor. So it makes us a little bit more flexible that way.
Okay. Okay. Brent, you're just A side on yours, right?
Oh, we got AB on ours.
You got AB? Okay. I remember I saw your video of your old system was AB as well, right?
Yeah, yeah. So both of our machines were AB, and kind of for the stuff we do, the smaller parts, it just kind of makes sense. Where it's
Yeah.
kind of high volumes, a bit smaller parts. It pretty much that's the only way to do it, in my opinion.
Yeah, I think that's a good point, Brent, is the size of parts you're doing, the program length you're working with makes a big difference on if it makes sense for you to do an A side, B side. For us, we're looking at cycle times that are around an hour on average. So a 5 minute changeover is really not that crazy on that kind of time. However, if you're looking at 5 minute cycle times, a 5 minute changeover is quite significant. So I think that's something worth considering.
Yep.
Question for me, the RFID identification of the jig as it approaches the robot, is that something that was developed for you, or is that something that was part of the robot scope of supply?
Part of the robot scope of supply. So Innovair has developed this system as they basically saw it as a requirement for the industry and they didn't see one somewhere. And so it's something that we purchased with the robot.
Okay. Okay. And last question that I see here, and if there's others, please put them up there. Martin is asking, how important is it to have active seam tracking and laser touch sensing for a robot cell?
From our side, it's very important. It's basically, I don't think that we would have close to the confidence that we have right now without it. We have a lot of really long parts and angles make a big difference on long lengths. And so the seam tracking basically allows us to correct for that. The laser touch sensing, we use it on an as need be basis. It still takes time to touch sense for things, so we try to avoid it, but it is another tool in your pocket. If you don't want to locate something with a jig, now you actually have some flexibility with the touch sensing. But out of the two, if I could only choose one, I would go for seam tracking all day.
Okay. Any thoughts there, Brent?
Yeah, kind of the same sentiments. They're both good to have. Seam tracking is really good if you're doing longer parts. We have the ability to go up to a 60-inch weld within our robot, but we don't have any parts that actually are that long of a weld. So yeah, seam tracking is definitely good. Touch sensing can be great in the right applications. It's not an absolute have to, but it's helpful.
Okay.
Yeah, when you're looking at the cost of a robot, adding touch sensing isn't really crazy expensive. So you might as well do it right away. So you have the program and the feature if you need it.
All right. All right. When's the pizza party, Jean-Marc?
That's what Theo was asking me. We'll see once this robot's actually in production and is pumping out parts consistently, then I'll be happy to do a pizza party and celebrate our wins there.
Oh, good stuff. Good stuff. What did you, Brent, you do anything with your staff upon getting the robot up and running?
All that we did really, it probably wasn't quite so momentous as what Jean-Marc's got going on there. But I don't remember that we did anything. We were just happy we had a robot that worked.
Makes good sense. Well, hey, I'd like to thank both of you guys for presenting today. It's not often that you hear company stories of robotic integration with the word awesome. with the words that we're doing production parts. We've got plans to go to full production. I'm starting to remove my engineer from the project because we're getting far enough along that we've got it integrated. You guys use so many positive adjectives describing your process. That is just so nice to hear, when previous to this, all I heard was, no, it doesn't work, not flexible, doesn't really work for the types of things that we do. So I'd like to thank you guys both for your presentations. And thank everyone that's on the webinar for taking part. We're going to have this posted on our recordings or our webinar tab on our website at vtci.ca. You'll have that up tomorrow morning. And again, thank you very much, guys.
Awesome. Thank you.
Thank you.